Okay, so let's try the next coding exercise. So open the leetcode.com and go to the problems tab and just scroll down, and in the search question, search linked list cycle and hit enter. So there is a question number 141 and it's come under the easy category. So let's see. So let's read the question. Given head, the head of a linked list. So we have some head is given. So this is the head. If you see the right hand side where I have highlighted, this is the head. So head is some parameter, and this is the head of the linked list. Determine if the linked list has a cycle in it or not. So we have to check whether the linked list has a cycle or not. There is a cycle in a linked list if there is a sum node. If there is a sum node in the list, that can be reached again by continuously following the next pointer. So by continuously following the next pointer. So let's suppose first we are on the 3, we will do 3 dot next, we will come to 2, then 2 dot next, we come to 0, 0 dot next, we come to -4, -4 dot next, we are again coming to 2. So by following the next pointer, if we reach to some node in the list, that can be reached again because 2 already reached, now 2 again we reached. So it means that means there is a cycle in the linked list, and if there is a cycle in the linked list, then we have to return true, otherwise we have to return false. So as an example, if you just by see this diagram 320 minus 4, we see there is a cycle in the linked list. 1 and 2, there is a cycle in the linked list, only single element, so there is no cycle. All right, so how to solve this question? All right, so there are two approaches. One approach is using some extra space, one is without using extra space. So what we can do is, so let's look by the diagram. So what we can do is, let's suppose this is the linked list. So our head is pointing to this. And so what we can do is we can use some extra space. Why we have to use extra space? Because we will store the node whichever we are like, whichever it is coming. As an example, so let's suppose the head is on pointer 3. So we will run a loop till head not equal to null. Right? So head is on pointer 3. So we are going to store the node 3. So we are going to store the node 3 in some set. So we are going to store the node 3 in some set. Now our head pointer will go to the next node. Sorry. So now our head pointer is here. So now we are so we will, so when the like when we reach the first node, we will check whether this node is in this extra space or not. It's not, we will store it. Then we are going to move our head pointer by using head is equal to head dot next. Then we will check whether this node is in our space or not, in our storage or not. No, it is not. Then we are going to again store it. Then we are going to again store it. All right. Okay, so we have stored it. Then we will move our head pointer again to the next position. Then we are going to, 1 second, Control C. Then we are going to move our head pointer here. Right. So now we will check whether the 0 is in the our extra space or not. 0 is not in the extra space. So we are going to store. Okay, so we are going to store. Then we will move our head pointer further. Then we are going to move our head pointer further. Then we will check whether -4 in the extra space or no. So it's not there. So we are going to again store it. So -4. So we have stored the -4. Then we will do again head dot next. So head dot next is pointing to back to 2. So head dot next is pointing back to 2. So then we will, before store, we will check whether 2 is in the extra space or not. So 2 is in the extra space. So it means the node which we already uh, reached, again we have visited. So it means there is a cycle. If like there is, we will like do, if there is a no cycle, then we will not find the node. So let's try to implement using some extra space. So what we have to do is we have to take some extra space. So we will take some extra space. S is equal to, we will take a set, because set contains the unique elements, right? And we will do while head, or while head is not none, right? Because while, until unless we will run the loop until the head is not none, right? So if head in S, that is head means if that node, the current node is in our set, then return true. It means we have found the, cycle. Else we are going to add our node into the our extra space that is set, and then we are going to our move our pointer head is equal to head dot next, right? And then we are going to return false. By default it is going to return false. So let's try to run it. So all the three cases has been accepted, so let's try to submit it. So our solution has been accepted and we beat 82% of the people, but we consumed a lot of memory, right? And if you read the question and if you scroll down, there is a follow-up. So it is just a follow-up question. The solution is perfectly correct, but there is a follow-up. Can you solve it using big O of 1? That is a constant memory. Right now we are using some extra memory, but can you solve this by without using some extra memory? So yes, we can solve it without using the, without using the memory. So let's try to see the approach. All right. So the next approach is, what we can do is, so this is the first approach in which we are just like using some extra space, and we are like traversing through the linked list. And as soon as we reach the node, we are checking if it is in the set. If it is in the set, it means it already exists. And then we are returning true. If it is not in the set, then we are storing it. All right. So the next approach is, what we can do is we can take the two pointers. All right. We can take the two pointer. One is the slow pointer and one is the fast pointer. So what do you mean by the slow pointer? Slow pointer will move step by step. That is slow is equal to slow dot next, one by one. The fast pointer will move by two step. That is fast is equal to fast dot next. That is the next to next node. All right. And then we will check whether the fast pointer can catch the slow pointer. If fast pointer can catch the slow pointer, and what does this mean by catch? Catch means like both the slow and the fast pointer reach at one place. Then we can say there is a cycle in the linked list. Otherwise, there is a not and cycle, in which we are not using the extra space, but we are using the two pointers. All right. So let's see using the diagram. So we have some linked list 3, 2, 0, -4, and we know there is a cycle. So we are using the two pointer. So because we are running one pointer very fast, we are running one pointer slow. And if fast pointer is catching the slow pointer, it means it reached again to the same point. It means there is a cycle. So slow and fast. All right. So we will move our fast pointer by fast dot next. So currently fast and slow pointer will point to the head node. So head is this. So we will move our slow pointer to slow dot next. So slow dot next means the next element. We will move our fast pointer to fast dot next to next. So it means to 0. So right now we are here. Okay. Then again we are moving our fast pointer to next to next and slow pointer to next. So fast pointer is 0. So next means -4, next to next means -2. So fast pointer will reach to -2 and slow pointer means slow dot next. So slow pointer will reach to 0. Then we are again moving our slow pointer to slow dot next. So slow will reach to next node -4 and fast will move fast dot next. So fast is reaching the -4. So both the pointer will met. So if both the pointer will met, it means fast pointer catches the slow pointer. It means there is a cycle in the linked list. Otherwise, there is not a cycle in the linked list. So how you are going to implement? So we have to take the two pointers, slow and the fast. So both will point to the head. So we will take the two pointers, slow pointer, which is the head, and we will take the fast pointer, which is also the head. Okay. And till when we have to run a loop? So while head, sorry, not head, while slow is not none, because and fast is not none, and if slow is not none, like maybe like let's suppose if there is not a, as an example, one. So fast is there, slow is like slow will point on the like pointer one, and fast is also pointer on the node one. So fast is not none, slow is not none, because if there is no node into the linked list, then we can't like move forward. So that's why we are taking this. And slow dot next is not none. Why we took the slow dot next is not none? Because of the single element. Because if there is a single element, right, slow is not none, fast is not none, and we have to move slow pointer by one. So slow dot next find none, and we have to move fast pointer by two steps. Fast dot next to next, but there is a nothing. Fast dot next is none, but none dot next there is nothing. So our code is going to fail. That's why we have to put this condition: slow dot next is not none. Okay. So this is a while condition. Then what we have to do? We have to move our slow pointer to slow dot next. We have to move our fast pointer is equal to fast dot next. Then we are going to check if slow equal to fast, then we are going to return true. All right. Otherwise, we are going to return false. So if both the pointer met, then we are going to return true. Otherwise, we are going to return false. So let's run it. So there is a syntax errors. So perhaps you forgot a comma. Or what we can do is slow not equal to none, fast not equal to none. No. All the three cases have been accepted. So let's try to submit it. None type object has no attribute. Next. So, oh, sorry, no, it should be fast. It should be fast dot next. So let's try to submit it. So now you could see our like runtime is decreases because we are taking two pointers and so it is like fast pointer will like run again and again and again until it catches. All right. So that's why like runtime like increases, but the memory we are using very less, and we beat 57% of the people. Earlier we beat 17% of the people, because right now we are using the very less memory. So that's the end of the video. So you can also try, and it's come under the easy category. If you use the extra space, then it is very easy. If you are not using the extra space, like it's the follow-up, can you try? Just a try. Can you try? Yes, we can try. But then you can like use the two-pointer approach. So just keep in mind, like if we have to, like in any, like what I notice is generally in almost all the scenarios, or maybe approximately 80 or 90% of the questions, if we don't have to use the extra space now, then normally start thinking use the two pointers. in any question. Doesn't matter whether it's a linked list, it could be even a simple list. Then we can start thinking the two pointers. Then first we understand the two pointer, then we can think how we are going to move the two pointers. Okay, so because in the linked list, only in the one direction the pointers can move. That's why, that because this is a singly linked list. Okay, that's the end of the video, and thank you. You can also try.